All right, so let's start. So here in this lecture, I'm going to solve some of the classwork problem from chapter number 19. Okay, so let's start with question number 1. So here we are given this circuit with a resistor with resistance R, internal resistance 0.5, and then the electromotive force with 12 volt. Okay, and we have to calculate these: the current, the terminal voltage, the power dissipated in the resistor R, and also in the internal resistance small r. Okay, all right, so let's start with the first one, number A. So you can solve this problem in many different ways. Okay, so I'm solving in one way, but it doesn't mean that you have to follow this. Okay, you can solve it in any way. Okay, so here what we are given the resistance R and the internal resistance small r, and you see they are connected in series. Okay, so the total resistance or the equivalent resistance here is this R plus small r, and the capital R is 65 ohm and small r is 0.5 ohm. Okay, so the equivalent resistance is this. Okay, and then from Ohm's law you know that V equal to IR. Okay, or I equal to V over R. Okay, so by using this equation we can calculate the current in this circuit. So if I write this equation for this circuit, it will be something like this: I equal to the electromotive force. So here the voltage is the electromotive force and R is the R equivalent. Okay, so if I plug the value of um, electromotive force and the equivalent resistance, we get the current that is equal to 0.183 amp. Okay, all right, next one is the terminal voltage. Okay, so we can use this equation to determine the terminal voltage. So terminal voltage means that the voltage or the potential difference between point A and point B. Okay, and if you remember that we learned an equation something like this: terminal voltage is equal to the electromotive force minus the voltage drop in the internal resistance. Okay, so here the terminal voltage is 12 volt, current is 0.183 amp. Okay, and R is 0.5 amp, 5 ohm. So if you plug all these values in your calculator, you should get 11.9 volt. Okay, so you see that the terminal voltage is very close to 12 volt. So that means the voltage drop here in this internal resistance is very small, and that's why in most of the problem we are going to ignore it. Okay, the last one is the power dissipated in the resistor capital R and also in the internal resistance. So PR, which is the power dissipated in the resistance capital R, is this: I square R. And as the same current flows through both R and R, I mean small r and capital R, then we can write this. Okay, so the power dissipated in this resistance, in this resistor, is just this. Okay, And similarly, you can determine what is P small r. Is the exactly same equation, but you have to replace capital R with the small r. And then the power dissipated uh, in the internal resistance will be very small. Okay, it is 0.0167 watts. Okay, all right. The next one. Okay, so the next one tells us that we have two different circuit. So two filament bulb are connected in series here and here in parallel. Okay, now the question is um, which which configuration produces more light? The first one is this, and then second one is which way do you think the headlights of a car are wired? Okay, so here we are ignoring the change of filament resistance R with current. Okay, all right. Now to answer the first question, okay, you have to remember that more light means more current. I mean, more current means more light. So we have to understand where we get more light. Sorry, more resistance. What is the uh, equivalent resistance here? In this circuit and in this circuit. So if you can determine that, we can immediately tell that which one produce more light. Okay, now for simplicity, let's say the resistance of this one is R, resistance of this one is also R. Okay, so when they are connected in series, the equivalent resistance here will be 2R. Okay, so R plus R. But when they're connected in parallel, then you see that it would be something like this: 1 over R EQ, 1 over R plus 1 over R, right? So it is 2 over R. So R equivalent for the parallel circuit is half of R. Okay, so here R equivalent is equal to R over 2. Okay. Okay. So for let's say for simplicity, let's say R, the value of R equal to 100 ohms. Okay. So if value of R is 100 ohms, then here the R equivalent is 200 ohms. And here R equivalent is 50 ohms, right? And since the battery is the same, okay, we can use the Ohm's law to determine the current, right? So the current is V over R equivalent, okay, for both cases, okay. And here 12 divided by 200, and here it will be 12 divided by 15, sorry, 50, right? So you see that this is more, right? The denominator small means I is more. So I is more means it produce more current. I mean more light. So I more means more light. So the parallel circuit, parallel connection produces more light. So the answer for the first one is parallel connection. Okay, why? Why it is the parallel connection? Because it produces more current. More current means more light. Okay. All right. I can also show a simulation. Okay, so let me show the simulation. I think no, I cancel it. Okay, so you can use the yeah, you can use a PHET um, PHET simulation to see that. Okay. All right. All right. So, but yeah, the key here is more current. More current means more light. Okay. All right. Now the second one is how the headlights are connected in a car. Okay. So the normal way, I mean, normally how we connect is this. Again, the parallel. Why it is parallel? Because you know that if somehow one headlight is broken, the filament, if one headlight's filament is broken, let's say this one is broken. Okay, so if it is broken, then you see that it is not a complete circuit. So here here we have a broken filament. So because there is a broken filament, that is it's not a complete path for the current. Okay. So one filament bulb is broken means the whole circuit is um it's gone, right? It's not now a circuit. Okay, it's not a complete circuit or complete path for the current. On the other hand, here if they are connected in parallel, so one filament, if one filament breaks, but still you see that there is a complete path for the current. Okay, so if one is broken, there is a still other will work. Okay, so that's why the headlights are connected in parallel. In series, if one is broken, that means the whole circuit is broken. Okay, that is it's not a complete path for the current. Okay, so that's why in that's why in um, car headlight, we use the parallel connection. Okay, the next one. So again, we have two circuit, one series, one parallel. Okay, so again, it says that the resistances are 100 ohms. So both R1 and R2 are 100 ohm resistors. And now the battery is 24 volt. Okay. So here we have to determine what is the current through each resistor. Okay. So we have to calculate what is the current in resistor and what is the equivalent resistance. Okay. And we have to calculate both for the series and parallel circuit. Okay. So first let's start with the parallel circuit. Okay, parallel circuit means this one. Okay, all right. So how to determine the equivalent resistance? You already see in the last problem how I calculated the equivalent resistance, right? So it's basically the same thing. Okay, so but yeah, let me show it again. So R equivalent for parallel circuit is this: R1 plus R2. Here R1 is 100, R2 is also 100 ohms. Okay, so it is basically 2 100. Okay, so if I reverse it, okay, then it will be R equivalent 100 2, so it is 50 ohms. So for the parallel circuit, the R equivalent is 50 ohms. Okay, now that is one part. Okay, the equivalent resistance, and then it asks us to calculate I1 and I2. Okay, so how to calculate I1 and I2? We can use Ohm's law. So you see that in this circuit, as R1 and R2 are connected in parallel, the voltage drop here, okay, in this line, and in this line are the same, okay, because they are in parallel. Okay, so parallel means the voltage drop are same. Okay, so using the assumption that the resistance of the wires are very small. Normally we use that assumption. Okay, so so then we already know what is the voltage drop here. Okay, so the voltage drop here is 24 volt, and also here 24 volt. Okay, so as we know the voltage drop and the resistance, okay, we can easily calculate I1 and I2. So I1 will be uh, V1 divided by R1. So it's basically the Ohm's law. Right here, V1 is 24 volt and R1 is 100 ohm. Okay, so it is equal to 0.24 amp. And the same thing for I2, it would be V2 over R2, and V2 is also 24 volt and R2 is also 100 ohm. So the current through R2 will also 0.24 amp. Okay, and using the junction rule, you can say that I will be I1 plus I2. Okay, so the current that draws from the battery will be the sum of I1 and I2. Okay, and it would be 0.48 amp. Okay, although it didn't ask you to calculate, so I'm just showing you may need this information for some other problem. Okay, all right, and then we have to do the same thing for the series circuit. Okay, and you know that for series circuit, calculating R equivalent is very simple. You have to just add them together. So 100 ohms plus 100 ohms, it will be 200 ohms. So this is the equivalent resistance. Okay, and you see that there is only one way current can goes. Okay, so the current will be same for R1 and R2. Okay, the same, actually same current goes through R1 and R2. Okay, and how to calculate that? Again, the Ohm's law is useful, but you can also use the loop rule here to calculate I. Okay, but let's use the simple thing. Okay, that is the Ohm's law. Okay, and you can simplify this circuit as this. Okay, this is R equivalent and this is V. Okay, and this is the direction of current. So current will be V over R equivalent. Okay, here V is what? V is 24 volt and R equivalent is 200 ohms. Okay, so the current here is 0.12 amp. Okay, so you see that it's basically the same thing that you learn conceptually in the last problem. Okay, so here you see the less current in series circuit. Okay, all right. Number 4. Okay, so here you see that it's a complicated circuit, and here you see that this one and this one, these two are connected in parallel, and that whole combination is connected with this one as a series. So you see that it's mixed between series combination and parallel combination. Okay, all right, now what we have to calculate, we have to calculate the current that is drawn from the battery. So we basically need to calculate I. Okay, and again, there are many ways to solve this kind of problem. Okay, so I'm solving in one way. You can solve in your in any method. Okay, okay, So the first thing here you have to determine is the R equivalent. Okay, so how to do that? So to do that, first let's find the R equivalent between 500 and 700 ohm. Okay, and let me call it RP. Okay, because they're connected in parallel. So how I should do that? It will be something like this. Okay, now this the 1 over 500 and 1 over 700 gives me something like this when I plug this in my calculator. 0034. Okay, now if I reverse it, okay, I get RP, and reverse means something like this. uh, I mean either this, or you can just do 1 over 0034. Okay, and that gives me 294 ohms. Okay, all right, so the parallel combination, the equivalent resistance between 500 and 700 is 294 omega. Now this 294, so if I simplify this circuit, it would be now something like this. So here we have 400 ohm, and then here these two becomes one equivalent. When we make combine them, I can just draw one. Okay, so something like this. So here we have 12 volt, and this is 400 ohm, and this is 294 ohm. Okay, now you see there's a simple circuit, and you see that 400 ohm and 294 are connected in series. So the equivalent resistance will be 400 plus 294, and that is equal to 694 ohms. Okay, so what is the current? You can use the Ohm's law. Okay, so Ohm's law tells us that, sorry, 12 volt divided by 694 ohms, and that is equal to 0.0173 amp. So this is the current that is drawn from the battery. Okay, all right. Okay, now it says that what is the current I want through the 500 ohm resistor of question 4. Okay, so here it now tells us that, okay, so let me, so the current I we get, or we just calculated, I mean this current actually follow these resistors. After this resistor, it will divide it into two parts here. One part will go in this direction, and one part will go in this direction. Okay, so I1 and I2 will be different. Okay, and then uh, they meet here at this point. Okay, and then become again I. Okay, but here I1 and I2 are different, so we have to calculate I1 and I2, or just I1. Okay, so how to do that? Okay, so to do that, let's say, because we now know the current through this. Okay, I mean we know I, right? This I we already know. So the current through 400 ohm we already know. Okay, so because we know that, we can determine the voltage drop at 400 ohms. Okay, so voltage drop at 400 ohms will be I times R. Okay, V equal to IR. So here I want to know what is the voltage drop in the resistor 400 ohm, and that is this. Okay, and that I got 6.92 volt. Okay, so what it tells us, that 6 point out of 12 volt, 6.92 volt drops here. Okay, and the rest of the voltage drop here, I mean in the parallel circuit. All right, so what is the rest? 12 volt minus 6.92 volt, and that is equal to 5.08 volt. Okay, so 5.08 volt basically drops in the parallel circuit. So here, I mean in AB, so we can call VAB, right, the voltage that drops in 400 ohm, as 6.92 volt, and VBC we can call it 5.08 volt. Okay, and you know that because 500 ohm and 700 ohm are parallel, okay, the same voltage basically drop in both resistors. Okay, so 5.08 volt is dropped both in 500 ohm and 700 ohm because they are in parallel. Okay, so then it's easy to calculate what is I1. So I1 will be VBC divided by 500 ohm. Okay, because again it is the Ohm's law, I equal to V over R. Okay, so what is VBC? VBC is 5.08, and we already know this is 500 ohm, and this gives me 0.0102 amp. Okay, and similarly you can determine, although it didn't ask you to calculate I2, but you can determine easily by using this equation. Okay, and um and if you add them together, you should get back I mean if you add I1 and I2, you should get back um I. Okay, all right, the last one is this one. I mean let me do this, and the rest of the problem I will be doing in the next lecture. Okay, so this is the last one for this lecture. So you see, this circuit is even little bit more complicated than what we are doing so far. Okay, so it has a battery, it has internal resistance, and you know the complicated combination. So here you see these and these are connected in parallel, and this combination is connected series with this one, and then that combination is parallel with this one, and then the whole combination is series with this one. So it's little bit of understanding. Okay, so you have to understand how they're connected. Okay, so let me go here. So I need some circuit to show you. Okay, in the solution I put already. So let me first determine the equivalent resistance between this and this. I mean this and this. Okay, you see they are connected in parallel. Okay, so when I connect, when I determine what is the equivalent resistance, I get something like this. So here you see 1 over Req 1. So here I call it Req 1. So 1 over 8, 1 over 4, and this gives me this, and then reverse of it is 2.7 omega. Okay, now the equivalent circuit is this. So here you see that this circuit is exactly similar to this circuit, given circuit, except now I replace this part with 2.7 omega. Okay, and these 2.7 and 6 are connected in series. Okay, so the equivalent resistance between these is just adding them together, and you see that I get 8.7 omega. So then I can draw another circuit. So this is 8.7 omega, and 10 omega is 10 omega. Now here you see that 10 omega and 8.7 omega are connected in parallel again. Okay, so then let's find the third equivalent resistance. Okay, and third equivalent resistance is this one. So 1 over 8.7 and 1 over 10. And then doing the same way, you can determine the equivalent resistance is 4.8 omega. So then if I draw this circuit, okay, replacing this parallel combination, I get this. Okay, now you see that it is very simple, right? So you see that I have this resistance, I have this resistance, and I have this resistance, and all are connected in series, because there is only one way a current can pass in this circuit. Okay, so in the last one, it is a series circuit. All the resistances are connected in series. Okay, all right, so once we know that, and then it's easy to calculate what is the current that is drawn from the battery. Okay, so we can use the Ohm's law to do that. Okay, or we can use the uh, loop rule. Okay, so here I use the loop rule, but you can also use the Ohm's law. Okay, so let me show how I use the loop rule, because here I use loop rule to solve this one. But as I told you, that you are free to use any method. Okay. All right. So to use loop rule, you need to know what is the current direction, because there is only one battery and this is positive terminal. So the current direction will be this. Okay. So this is the current direction, and let me call it current I. Okay, let me call this current I. And let me also follow the same direction. Okay, so this is let's say travel direction. Okay, so the current direction is my travel direction. So then if I write the loop rule, the equation for the loop rule for this loop, I get 9 volt, okay, minus I R, okay, minus I Req 3 minus I 5 omega equal to 0. Okay, so 9 volt minus I R is 0.50 omega. Okay, and you see that I and I are common in these three terms. So let me take I out, and then okay, let me write down one more term. So this is negative 4.8 omega minus I 5 omega. Okay, so if I solve this for I get 0.50 omega plus 4.8 omega plus 5 omega equal to 0. So I will be 9 volt divided by this 0.50 plus 4.8 plus 5. Okay. So if you do this calculation correctly, okay, you should get something like this: 9 volt, and this is 10.3 omega. So I is equal to 0.874 amp. Okay, and you see that this is exactly equal to the Ohm's law. All right, so although we start from the loop rule, you see that we get the Ohm's law, and it should be. Okay, all right, so we are done for the first part. The second part, it tells us to calculate the terminal voltage of the battery and the current in the 6 ohm resistor. Okay, so the terminal voltage is easy to calculate, and you know that is VAB equal to EMF, battery EMF minus I times R. Okay, so EMF here is 9 volt and I is 874 amp, and resistance, internal resistance is 5 ohm. Okay, so if you plug these values in your calculator, you should get back the internal the terminal voltage is equal to 8.56 volt. Okay, all right, so that's easy. The last one, it tells us that what is the current in this resistor. Okay, now we have to think how to solve. Okay, so you see that current I comes here, I enters here and divided into two parts. One goes in this direction, another goes in this direction. Okay, and also that current, if I call it I1, okay, then you see that at this point it also divided into two parts. Okay, I1 will be one part of I1 goes in this direction, another goes in this direction. So you see it is a little bit complicated. Okay, now loop rule, I mean we can use loop rule, but if I use here loop rule, okay, I mean if I want to use this, it will be a little bit complicated. Okay, so in order to avoid that complicacy, let's use this one. Okay, so let's use this loop. Okay, so you see that if I use this loop, that's a little bit easier. Okay, because here I mean we know that this is I, and then let's say this is I2 and this is I1. So you see that there is only one path here. Okay, the same I1 is going through 6 ohm and also the equivalent resistance. Okay, and then this is again I. Okay, I we already know. Okay, so the only unknown here is I1. But if we use this circuit, okay, the first one, the given circuit, so the problem will be the current here will be I3. Okay, so here we have two unknown. Okay, so two unknown will be uh, difficult. I mean, it's doable. You need two equations, but if we use circuit number B, then you can just use only one loop and get back get the value of I1. But if you use the given circuit, then you need to know you need to use two equations. Okay, so let's not worry about that. Let's use circuit B and that loop. Okay, now let me draw it here, the loop. Okay, so here we have the battery. Here we have the internal resistance, and then here we have 6 ohm. Okay, and then here we have that 2.7 ohm. Okay, 2.7 ohm. Okay, and then here we have 5 ohm. Okay, so this is the lower loop in circuit B. Okay, now you have to understand that this current and this current are different. Okay, so here we just draw the lower part. I mean, it's not the complete circuit. We just draw the lower part of the loop. I mean, lower part of the circuit. So you know that this will be different. So it will be I1. Okay, and this is also I1, but here again it will be I. Okay, so you can go back to this circuit and you see that here it is I, here it is I1, here it is I1, and here it is again I. Okay, so you have to be careful here. So once you know that, then you can just use the loop rule. Okay, so you already draw the direction of current, so we just need to draw a travel path. So let's go again in this direction. Okay, then again our equation will be something like this. So if I start from the battery, so it will be 9 volt, and then I R, and then I1 6 ohm, and then I1 2.7 ohm, and then minus I 5 ohm, that is equal to 0. Okay, so this is the loop rule equation, and you see that everything you know except I1. So if I solve it for I1, I get something like this: I1 6 plus 2.7. Okay, and then plus 9 volt minus I is 0.874, small r is 0.5 omega, and then minus 0.8745 omega, that is equal to 0. Okay, so you can easily solve this equation for I1. Okay, so you see that all are numerical value except I1. So if you solve this, okay, so here I did it. Okay, so if you solve it, you get something like this. Okay, the second line is so 9 volt. This is the internal resistance. You get this. This we don't know, this we don't know. So if you, when you add them together, you get something like this, and then this term gives you this. So if I add all the numerical values, so these, and this, I got this, and I have this. Okay, and then if you solve it for I1, you get 0.482 amp. Okay, so I'm going to stop here. If you have any question, let me know. Okay, so you need little bit of understanding here in this problem. Okay, so please go through it and let me know. And there are a few more questions here. I'm going to do it in the next lecture. Okay, all right.